Okay, grade 12s, in this lesson what I want to do is prove the proportionality theorem. But before we do it, we need to look at some basic information with triangles. Now look at this. If this is triangle ADE, okay, that's triangle ADE. What we can do is we can call DE the base, and the height would be the perpendicular height which corresponds to that base. Notice too that you could also have, if you look at triangle ADE, you could also have a different base. So what you could do is, if you decide that AD is the base, then the height would correspond with the base. It almost looks like a T, base and height. But if you draw a triangle onto this triangle ADE, say you do that, I want you to notice this. There's a triangle ADE, and then we've got AEF. Notice with this triangle, that would be the base, but the height is identical to the height of triangle ADE. And that's important because we're going to use this information a lot as well. So watch out, your base is chosen as you wish. The other important thing that I want you to notice, that if you've got parallel lines, now this is an important thing from earlier, from certain geometry theorems that we don't really do in grades 8, 9, 10 or 11, and in 12 we don't do it, but it's something worthwhile for the proof. If you've got two parallel lines, and you've then got a triangle doing this, like that, and we can call that triangle ABC the purple triangle, and then we have let's have a little green triangle here, that goes like this, comes up and down, and we can call that T. Do you notice that the important thing here is that the triangle ABC and the triangle BCD have the same base, and obviously they have the same height, and they also lie between parallel lines. So not only do they lie between parallel lines, they have the same height and the same base. And if that's the case, we can say that the area of triangle ABC is equal to the area of triangle BCD. So this triangle here has exactly the same areas, that if they have the same base, same height, and they lie between parallel lines. Okay, so let's prove the proportionality theorem using all this information. Now, a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. So what we given? We given that DE is parallel to BC. Okay, so we given that DE is parallel to BC, and what we must prove is we must prove that AD over DB is equal to AE over EC. So AD over DB is AE over EC. Now this is very easy to do, and we're going to do a few little constructions here. So what I'm going to do firstly, I want you to look at triangle ADE. I'm going to choose my base to be AD. Now if AD is my base, then my height of triangle ADE would be H there. Okay. Now what I could do, and I want you to look at carefully, you could also make AE the base. Now if AE is the base of triangle ADE, then your height would be relative to that base, which we can call something else like K. Now another very interesting thing that you can do, and I want to show you something, this is really cool, is if you join B to E and D to C, you get this scenario of triangle ADE. Now watch this, this is quite cool. You've got triangle ADE there, okay. Now watch this carefully. You've got triangle ADE, and if you extend that, you now have triangle BDE. And if I look at this height, it's shared by both triangle ADE and BDE. They have the same height, although they have different bases. This one will have a different base to ADE. But if you also look at this, watch here. If you go like this, you've got triangle ADE, but what if you go like this? What do we have? Well, this is a C there. Now look at this triangle. they both share the same height, which happens to be k. Okay, so there we go. So that's out of this here. You've got triangle ADE with triangle BDE and DEC. Now, what can we do? I want to show you something very interesting here. We can say the area of triangle ADE divided by the area of triangle BDE. If you look at this one here, the area of triangle ADE is a half the base, which of course is AD, multiplied by the height, which is h. Now for triangle BDE, it's a half, the base is dB, there we go, and the height is the same. Now what happens is that the h's and the halves cancel, and you're left with AD over dB. Okay, you're left with that. Alright, now that gives us then the first fraction, AD over dB. What about AE over EC? Well, look at this triangle, these two triangles on the right here. If we say the area of triangle ADE divided by the area of triangle, now watch this, this is CED. So the area of ADE, and then this one CDE, is equal to, for the top triangle AD is a half the base, but the base here is relative to k, so the height k. So the base is AE, and the height is k, and the bottom triangle CED, this one is a half base, which would be EC, multiplied by its height, which is the purple height k there. And then the halves and the k's cancel, and we're left with AE over EC. Now, how do we get them to equal each other? Very simple. I want you to look at this. Do you notice something interesting here? That if you look at this triangle here, this is BDE, okay, and this one here is DEC. Do you notice that they actually have the same base? Okay, they've got the same base. Look at that. And that base is DE. So it's the same base. They lie between parallel lines, but now look at this. If you watch this, if I extend that a little bit there, these parallel lines, watch this. If you look at BDE, its height is that line, and the height of BEC is this one. So they have the same heights as well. Do you see that there? And they lie between parallel lines. You can call it whatever you like there. Okay, now what we can say then is that, look, and this is so important. Can you see that, firstly, if you look at this area here, the area of ADE is identical to ADE. That's not a problem. But what about these two? Would these be equal? Well, let's see. What we've got is we've got the area of triangle BDE, and we've got the area of triangle CED. Now, why would they be the same? Think about it. Well, the area of triangle BDE is this dotted guy here, and the area of DEC would be that shaded triangle there. They both have the same base and the same height, and they lie between parallel lines. Therefore, those areas are equal. Why? They have the same base, the same height, and they lie between parallel lines. Which means that if they're the same, then what we've got here is we've got a situation which says these guys are the same. Now look, if the top areas are the same and the bottom areas are the same, we can therefore conclude that AD over DB is equal to AE over EC. So we can therefore say, therefore, and if we do it properly in black here, we've got AD over DB is equal to AE over EC. See there we go. And there we've got it there. So all you did was you did the construction, and you had these little lines in the triangles constructed. You got the areas, the ratio of the areas, ADE over the left one, ADE over the right one, and there we go. And here's the scenarios where it happened there. Okay, and then what we then did is we got the two fractions. But we know that the area of triangle BDE, this triangle's area, and this other triangle's area, this guy, They're the same because they have the same base. There's the base, the same perpendicular heights, and they lie between parallel lines. And therefore we've got it. We've then proved the proportionality theorem.